Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter atomic structure. In this session, we are going to say about different atomic models proposed by scientists. At the starting, they have given some proposals and models of the atom, but because of some limitations, so they were failed. So what are those different atomic models? How they were proposed? What are the drawbacks in those earlier atomic models? Now let us see. First among them, Thomson's atomic model. Actually, John Dalton suggested that the atom was indivisible and indestructible, isn't it? The first concept of atom was proposed by John Dalton. We studied that. He told that as atoms are indivisible, they cannot be. There are no some other smaller particles than atom. Atoms are the smallest, and they cannot be broken into smaller still, and they are indestructible. They cannot be made into simpler. But the discovery of two fundamental particles, namely electrons and protons. So the discovery of these two fundamental particles inside the atom led to the failure of this aspect of Dalton's atomic theory. What did he told in the theory? Dalton told that atoms are the smallest particles, but they discovered electrons and protons which are existing inside the atom. So atoms are no more smaller particles. That is why Dalton's atomic theory was failed after the discovery of these. So they have discovered the particles present inside the atom and they are called fundamental particles. It is good. Then it was considered necessary to know how these electrons and protons are arranged within the atom. They came to know as these particles are present inside the atom. If they are present, how they are existing inside the atom, how they are coexisting inside the, how these are arranged in the atom is necessary to know. So for explaining this, many scientists proposed various atomic models. Actually, how these electrons and protons are arranged inside the atom. To explain this, different scientists they have done different experiments and they have given different proposals about the arrangement of these fundamental particles in atomic models. So out of them, the first one is J.J. Thomson's atomic model. So J. Thomson was the first one who proposed a model of structure of the atom. A model for the structure of the atom. Who was that? J.J. Thomson. We know as he was a scientist who discovered electrons also. So after the discovery of electrons and protons, again the same scientist J. Thomson, he proposed a model of atom to explain the structure of the atom. According to his model, an atom is made up of positively charged substance which is spread very thinly in the form of a sphere. So he considered the atom is in spherical shape and it consists of positively charged mass. So positively charged mass is spread over in the atom in a thin form of a sphere. Into this sphere, negatively charged electrons are embedded. So he considers total atom in the positive charged sphere. Into this positively charged sphere, electrons are embedded somewhere. Okay, in this way, he assumed the structure of the atom. This can be compared to a watermelon. Yes, J. Thomson's atomic model can be compared with a watermelon, which has evenly distributed red spongy mass with the black seeds embedded in it, isn't it? When you cut a watermelon to half, what do we see? Red pulp or red pulp is spread over in the watermelon. In this red pulp mass, black seeds will be embedded inside, isn't it? In the same way, he compared the atomic structure also with this watermelon. How this red pulp spread in the watermelon. In the same way, the total positive mass of the atom is spread over in the atom, just like the red pulp in the watermelon. And how these seeds are embedded in the red pulp in the watermelon. In the same way, electrons are also spread over in the atom in the total positive mass. So in this way, he compared the atomic structure or model of the atom with the watermelon. That is why his model is also known as watermelon model. The same model or the same concept also can be compared with some other fruits like apple pie or plum pudding. That is why the other names for the J. Thomson's model are said to be watermelon model, apple pie model, or plum pudding model. There are the different names for this water J. Thomson's model. So this was the first atomic model proposed by J. Thomson. Even though it was the first atomic model and has given some clarity about the structure of atom, there are some drawbacks or limitations in this atomic theory. So let us see here drawbacks of Thomson's atomic model. Although J. Thomson's model of atom was able to explain overall electrical neutrality of the atom, means he told that atom consists of overall positive charged mass. In that electrons are embedded, he told there. So he considered that the quantity of the total positive mass and the negatively charged electrons total charge. The quantities of positive charge and negative charge are equal. So the positive charge in an atom is counterbalanced by negative charge of the electrons and hence atoms are being neutral. So in this way, J. Thomson explained the electrical neutrality of the atoms. Why atoms are being neutral even though they have positive and negative charged particles. Because negative charge of the electrons is being counterbalanced by positive charge of these protons. Now, this model was not accepted by fellow physicists. Even though the explanation was given, it was not accepted by fellow physicists as it was unable to explain how positively charged particles are shielded from the negatively charged particles, the but electrons, without getting neutralized. He considered that these negatively charged electrons are embedded in the positive mass. So, if the positive mass and negative particles are being together, then they should be neutralized. When these two opposite charged particles are being together, they should be neutralized. But it is not being happened. Negative charged particles and a positive mass, they are existing continuously. As you said, if these two are being together, they should be neutralized. But it is not happening. Why it is not happening so, even though they are being together? For this, J. Thomson couldn't give answer, so it is failed. Thomson's model is failed because of this drawback. Next, one more scientist has given atomic model is Rutherford. So now let us see here about Rutherford's atomic model. To explain the structure of the atom, Rutherford, a student of J. Thomson, conducted an experiment called alpha-ray scattering experiment or gold foil experiment. So he was one of the students of J. Thomson. So later to him, after the failure of the J. Thomson's model, Rutherford tried to give explanation or to explain the structure of the atom. So to explain that, he did an experiment which is called as alpha-ray scattering experiment or gold foil experiment. So in this experiment, let us see here about alpha scattering experiment. In this experiment, Rutherford passed a beam of alpha particles through a thin gold foil. See, this is a experimental setup done by Rutherford. In this experiment, he passed alpha particles onto the thin gold foil. What are these alpha particles? First of all, so the combination of two protons and two neutrons. The bunch of two protons and two neutrons together called as an alpha particle is all together called as an alpha particle. Sorry, it can be represented like this. So this alpha particle is represented. So the bunch of the group of two protons and two neutrons is called as an alpha particle. Actually, to say simply, He plus two ions are called alpha particles, we say, isn't it? He2 plus 1 because helium contains two electrons, two protons, and two neutrons. When these two electrons are removed, then it becomes He plus 2 ion that contains only now two protons and two neutrons. This is called an alpha particle. But from the helium, we cannot produce these He plus 2 ions because it is the very smallest and noble gas. Now, these alpha particles are produced from some radioactive elements like radium, thorium, polonium, and these all. So, for his experiment, Rutherford has taken a radioactive element in the lead chamber. So, here some radioactive element, radium, is taken, which can produce these alpha particles. So what are these radioactive elements we are going to learn in the higher classes? Now, these radioactive elements, they'll produce continuously some rays like alpha particles. So as these rays are harmful, this is kept in a lead chamber. Only one outlet is there through one hole. Through this only particles will come out. Now, from these alpha particles will come out now from this radioactive substance. Now, these alpha particles coming out from this radioactive substance made to fall on a thin gold foil. A metallic foil is taken. Why only gold foil is taken? There is a reason. Gold is having one special property, that is high malleability. It can be made into very thin sheet. So the thickness of the sheet here taken is around 0.0004 millimeters. This much thin, very thin gold foil is taken to make to these alpha particles to fall on this. So as these alpha particles and these all particles are invisible to naked eye, to observe what is happening after striking the gold foil, he arranged a zinc sulfide screen around this gold foil. So this is the experimental setup done by Rutherford. He chose a radioactive substance which can produce alpha particles like radium. So he took a radium piece and he kept that in the lead chamber, which has only one outlet. Through that only alpha particles will come out, and he made these alpha particles coming out from the radioactive substance to fall on the gold foil and to observe what is happening after striking the gold foil. Around this gold foil, he arranged a zinc sulfide screen. Now he started to notice what is happening. Let us see observations done by him. There, he observed that suppose this is the thickness of the gold foil. Almost it is made up of one or two atoms made thickness. So this is gold foil. Now alpha particles are striking onto this. Let us consider this we are observing in the zoom after magnifying. Now he observed that most of the alpha particles are passing through the gold foil without any deviations. So and making some scintillations on the zinc sulfide screen at the back exactly. So what he observed, most of the alpha particles are passing through the gold foil. Even after striking also, they're coming directly and making scintillations on the zinc sulfide screen. Some bright spots are observed. So then from that he observed, concluded that most of the alpha particles are coming directly or straight without any deviations, even after striking the gold foil also. Okay, one more observation. A few rays got reflected after hitting the gold foil. So most of them they're coming directly under in the straight lines, and few of them they're reflecting after striking the gold foil. See here, this is coming straight and for making a scintillations on the zinc sulfide screen. This is also coming straight and making scintillations here. But if you observe this, after hitting the gold foil, it is getting deviated from its path. Instead of making scintillation here, it is making here. Means it is reflected. It is deviated from its path. So a few of the rays getting deviated from their path after striking the gold foil. This is one more observation. Next, one more observation done here. It is 1 in 1000 rays, means very few of them reflected by an angle of 180, means retraced their path, reflected back to their original path, means getting back exactly after hitting the gold foil. So very few of them getting back to their path after hitting the gold foil. So these are the observations, major three observations done by Rutherford in his alpha ray scattering experiment. What are those? First one is most of the alpha particles directly passing through the gold foil after hitting it, and few of them are reflected from their path, are deviated from their path after hitting the gold foil. This is one. Third one, very few of them, 1 in 1,000 of those alpha particles getting exactly back to their path after hitting the gold foil. So these are the observations done here. So first one, if you see, most of them directly passing through the gold foil means most of the space in the atom is being empty. This is a conclusion given from him. And these alpha, some of them getting deviation from their path after reaching the nucleus of the atom, they are being deviated. From this, he told that the positive charge is located at the center of the atom. And one more observation, they're hitting the atom and coming back to their path. So when they hit the nucleus, means the total mass of the atom is concentrated at the center part of the atom. After hitting the center part of the atom only, these alpha particles are getting back to their path. So in this way, has given some conclusions from his observations. Let us see, based upon these conclusions, what model is given by him. So based upon the conclusions from the experiment, he proposed a model of the atom commonly known as Rutherford's atomic model. So he concluded that the postulates of his model, let us see here. A major portion of the atom is being empty, and the whole mass of the atom is concentrated in the center of the atom called nucleus. So suppose if we consider this as atom, the total mass is concentrated at the center. He called the center part as a nucleus. The term nucleus was first used by him for the center part of the atom. Okay, total mass of the atom is concentrated at the center part of the atom, center part called nucleus. Most of the remaining place is being empty, and the positive charged particles are present inside the nucleus. As I told, the total mass is concentrated at the center part called nucleus. In this nucleus only, all the protons are being accommodated. Okay, so the total positive charge is in the nucleus now. The size of the nucleus is very small as compared to the size of the atom. So the size of the nucleus is very small, whereas when compared to the size of the atom. So mostly atom is being empty. Only very small part of the nucleus is considering total mass. Now electrons are revolving around the nucleus at high speeds in circular paths. These circular imaginary paths where electrons are revolving around the nucleus with a high speed are called as the orbits. Whenever these electrons are revolving around the nucleus, there are two types of forces acting on these electrons. One of them is a centripetal force which pulls the electron towards the nucleus. So as electrons are negatively charged particles and the total positive charge is concentrated at the center, so between these two there will be some attractive force. That attractive force is called here centripetal force. This is acting on the electron. One of the forces it is. And the next force is centrifugal force, which is directed away from the nucleus. So as electrons are revolving with a very high velocity around the nucleus, these electrons will tend to move away from the nucleus. This tending force is called as centrifugal force. So these two forces, these two opposing and equal forces acting on the atom, so atoms are being stable. So these two opposing forces which are equal in magnitude, one it is pulling towards the nucleus and the other one is pushing the electron outwards the nucleus. So these two forces in equal quantity acting on the electron. So electron is continuously moving in the same orbit. So the atoms are being stable. Okay, in this way he explained the structure of the atom. So he considered the center part of the nucleus or center part of the atom as nucleus, and it is containing total mass as well as total positive charge. Its size is very small, and remaining most of the part of the atom is being empty. In this empty space, electrons are revolving around the nucleus in imaginary paths called orbits. So he compared this model of atom with solar system. How sun is being at the center of the solar system, the nucleus is being in the atom and the at the center. And how planets are revolving around the nucleus in imaginary Pascal orbits. In the same way, electrons are also revolving around the nucleus in imaginary Pascal orbits. So, in this way, he compared the model of atom with the solar system. That is why Rutherford's model of atom is also called as planetary model or solar system model. By this, he has given much clarity about the existence of atom and the structure of atom. Even though it is giving much clarity about the structure of the atom, there are some drawbacks. Let us see here now drawbacks of Rutherford's atomic model. There were two fundamental defects in Rutherford's atomic model. Even though it is giving much clarity about the atom, there are major two drawbacks. One of them is, according to classical electromagnetic theory, any moving charged particle moving at high speed in a circular path will radiate energy continuously. Not only circular path, if any body with certain charge, any charged particle, if it is moving with high velocity, that should radiate energy continuously. That will radiate energy continuously. Here, electron is also moving with high velocity around the nucleus, and we know electrons are having negatively charge. So these negatively charged electrons, if they are revolving with the high velocity around the nucleus, they should radiate energy continuously. So the electron, when it moves around the nucleus, should lose energy and get increasingly pulled towards the nucleus with a greater force. As it is radiating energy, means if it is losing its energy continuously, that will be pulled by the nucleus with greater force. Thus, the electron must spiral into the nucleus. The atom should be collapsed. So as it is losing its energy continuously, that will be pulled by the nucleus with greater force. So slowly that will radiate or it will spiral into the nucleus. At certain time, it will lose its complete energy and it should fall into the nucleus. When electrons fall into the nucleus, the electrons will combine with the positive charge present in the nucleus, so that atom should be collapsed. The atom should collapse if this happens. But we know atoms are being continuous. They are not losing their energy. They are not being collapsed. Why it is so? Why atoms are not being collapsed? Why electrons are not falling into the nucleus even though they are revolving with high velocity continuously? This was not explained by Rutherford. He couldn't answer this question. This is one drawback. One more, Rutherford could not explain why atomic spectra is discontinuous. So atomic spectra means here we have to, let us say in simple words, when atoms radiate energy, that comes out in the form of spectra. If we made this energy to fall on the screen, we can observe some lines on the screen. These lines are called as spectra. So when this is formed when atoms do radiate energy, so it is called atomic spectra. If it is observed through the microscopes, it is found that the energy emitted by the atoms is not being continuous. That is why there are different lines in the radiation emitted by the atoms. Why energy is not emitted continuously by the atoms? Why the emitted energy is being discontinuous? For this, Rutherford could not give any answer. So in this way, Rutherford's theory failed due to the major drawbacks, these two drawbacks. Why the energy is not being continuous, which is emitted by the atoms. And one more, why electrons are not radiating the energy even though they are revolving continuously around the nucleus. For these two, Rutherford could not give any answer. So this theory also kept failed. So these are the two important atomic models which were given at the earlier days. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos. Thank you.